to tell you a real quick story. I've been married for 34 years. I'll show you, this is my family. This picture is taken in Thailand. It's the last time we were able to get most of my family together. But I found out after 34 years that my wife was upset because I never bought her flowers. I didn't even know she sold them. But anyway, so a little bit about me. You can read this, but here's what's relevant for you to understand what I'm gonna talk to you about today. So at the end, talks about me being an operational technology architect for Aera Energy. Aera Energy is an oil and gas company. They have about 10,000 wells. They operate out of California, and I spent my entire career in that OT space until 2013, where I transitioned to IT. And I spent 9 years in IT, and part of that was as an operational technology architect trying to figure out how to extract OT data to derive value. And the pain and the struggle of trying to figure out how do you take uncontextualized, unmodeled data with horrible data quality and extract it and then get some kind of an ROI that's reasonable. And it was a failure at every turn. And then we got an opportunity to actually start working with Kelvin and some of their co-pilots and things really started to click for me. So what is cognitive AI or cognitive computing? So really what we're talking about is that cognitive knowledge that we all have, right? That information that just is tacit knowledge that as an operator or an engineer that I just know because I've worked in this equipment or in this process for 25, 30 years. Well, how do we take that knowledge and transfer it from that person to computing? And that's what we're here to talk about. So the problem is that we have too few of the right people, and as we talked about earlier, everyone's going through that process of resources and such. And we have a ton of people that are walking out of our companies, and they're taking all of that knowledge with them. And we've all gone down that path, and all of our companies have created processes and procedures on how we extract that data before they leave. None of it works. At least in my experience, it hasn't worked. So we had a problem. Our problem was asset prioritization. And so what we were wanting to do is figure out a way that we could solve the scalability of determining which wells to acidize. And what is acidizing a well? So when you produce an oil well, what happens is you drill the well, you run the tubing, you run a pump down there, and you begin to produce that well. The minerals that are coming through the perforations or the pump, or even the pores of the actual formation begin to, over time, build up. The well becomes less porous, the fluid doesn't flow as well, and you have to make a decision at some point to go down and clean that out, those minerals and the calcium, and clean it out so that you can open up those pores and the oil will flow. So the question was, how do we make sure that we're sending the equipment that's doing the acidation jobs to the right wells? And so that was the problem that we had. In that, I cannot see. I should have brought my glasses. I didn't. But in that, we had a senior engineer that was, we could never find out how much better he was, but all of the other engineers in the group said, if you want the best outcome, have that guy figure out which wells to acidize. And his method that he used, which was all spreadsheet driven, he knew where to go get the right data. He knew how to write his algorithms and do the things that he did to come up with a really good outcome. So what did we do? We partnered with Kelvin, and Kelvin has a software technology called co-pilots. And what co-pilots is the opportunity to connect that right engineer, right? That best engineer on his best day, connect that guy with a data scientist, super smart guy, with the right software. And so by getting those two people together, what happens is you begin to capture that knowledge, capture the data. Now you have a place to ingest the data, write the algorithms, and begin to capture or transition from cognitive knowledge to cognitive computing. Sam, oh, I gotta click the button here. Oh, so that guy, best engineer, best day, you just missed that slide. There you go, you got it? All right. Sam is actually an AI generated photo. It's a good looking guy. But this is the process. The process is you take your engineer and you take his spreadsheets and you find out his methods, right? What is he, not just what he's doing, but what's the nuances that he knows tacitly that he's applying and he's adjusting and he's tweaking. You begin to capture those things and then you begin to transition those into the software, which is co-pilots. So you capture the best practices, the standards, the operating procedures of the team, and you put it in the software. The impact is you begin to automate those mundane tasks for the engineers and the operators so that they can focus on what? Higher value work. And then again, it's just a matter of, I'm going to go ahead and go through these slides pretty quickly, but the point is we're trying to find out what those procedures are, what those things that guy is doing on a regular basis, capturing them. But the key is where you capture them. Is the software we're using to capture them the right software? And that's where Kelvin came in and really bridged that gap for us. So here was the value that we got from the prioritization for our acid jobs that we were doing. So we were able to capture that cognitive knowledge from that best engineer on their best day. We freed up our best engineers to continue in improving the processes and even whether or not they continue to work in that process, or you freed them up to go solve another problem that you've been struggling with. To have a process that's mapped, modeled, and contextualized. So now that acidation prioritization is modeled. We know where the data is, we know how to capture it, we know we have the algorithms there, and we can begin to, in real time, give an output on where we should be sending the hardware that does the acidation for those wells. And then we're a step closer to autonomous control or autonomous systems. And for us, we were projecting a 5-time return on the investment. All right, so how do we transition from really that human interaction in cognitive computing to the learning phase, right? And so this is where we begin to transition from, okay, we have captured that cognitive knowledge, we have it now in cognitive computing, you have the human interaction where they are helping that model learn, and how do you transition from that to allowing the actual AI to teach itself? And that's where Kelvin has a software called Autopilots that is very impactful. So it's a natural transition. Once you have that modeling software, once you have the contextualization and the modeling, now you can start to begin to transition from just doing the human interactive automation of those tasks to allowing the system to begin to learn. And this is what it looks like. So we have the opportunity at the lowest level to do what? We have to map out our processes. We have to be able to start capturing not just the simple mapping, but a process mapping. How do we do that? How do you do that with speed? And the way you do that is you have to get the right people and the right software together so that you can capture it, it's contextualized, you have all of that metadata that typically is not there in the OT space, and begin to put it in the software, which will allow you to validate those algorithms and then transition to learning which is autopilots, ultimately getting to autonomous systems. That was super fast, see that? Got you covered. All right, so here's a conclusion. Cognitive AI enables us to achieve operational excellence, all while achieving the goals that our systems today are requiring, all while preparing for an autonomy of tomorrow. Leveraging cognitive AI will free up and enable our change makers to find new value for the company, for our companies. And the following this process is fast. I don't know if you really understand that part of it, but that for me is the most important piece. The reality of trying to do this in the last really 5 to 6 years and failing over and over again because of the data quality, because of the lack of contextualization and modeling that's coming out of our OT systems. To be able to tie that engineer and the operators who have the context, they understand the modeling. When you can tie that person to a data scientist with the right software, you're going to begin to achieve in a very short period of time the opportunity to take that learning and get it to work for you. And ultimately, we want to move to autonomous systems. We want our systems to begin to learn and be more effective and free our people so that we can leverage those people for more value. That's it. That's all I got.